Today we'll be looking at the IO-Link master in greater detail. Today what we'll be focusing on will be the low speed data instead of the high speed data that we've been looking at until now. So the low speed data is very crucial from the point of dashboarding data, just making sure that all the data that you can see is correct if it's in the form that you require, and extra information like that. So let's see the kind of information we acquire from these IO-Link masters through our custom node, and surrounding information, which really makes using things like an IO-Link master very easy from a data perspective. So to take an example, uh, now we have two kinds of messages over here, which is one is the port status message, which just directly tells us at any point what is happening on any port, what is the status, is it operational, are there any errors that we found until now, and what the rest of the state of these particular ports is. The other side of it is directly processed data. Now this is the kind of processed data you get from a WIM32 sensor. We have more conversions that come after this. This will output direct acceleration and velocity and things like that after it has been taken care of. And apart from things that are available here, we can see data from all possible ports here, which is broadcasted according to any frequency that you require. Um, and this is almost as important as the high speed data, because this is the only way you can actually effectively dashboard data. Um, this is coming out through an MQTT interface right now. Apart from this, you can also pull data using your Modbus interface. And right now we are testing the system with around 3 to 4 different IO-Link masters. And so you can continually see if a particular IO-Link master is prepared for data collection and things like that through warning messages here. And it's basically a complete system around this particular principle. Apart from this, we also have converters for the kind of sensors that are available easily. The most heavily tested one is the vibration sensor available from Pepper and Fuchs. Apart from this, we also have surrounding data on if a particular port is inactive, uh, what the last bits are, what is the exact serial number of the particular sensor connected. All of this can be pulled out through your low frequency interface, and all of this builds together to make a universal connector, which allows you to basically connect any sensor to any port and it will just work fine. And so this is the stepping block to that particular state. We will look at that more deeply in the next video. Thank you.